2,3-dihydroxypropanal. So basically this is the compound that is known as glyceraldehyde, which is known as 2,3-hydroxypropanal, that was given this specific configuration by this German scientist that is known as Emil Fischer. Now in Fischer's argument, we're going to see that for the structural representation of this particular compound, I'm going just to do away with this so that we can have a space. So the structural representation for this, according to Fischer, was given as this one. I'm going to do an illustration for. So this basically is the representation of that particular compound that we have called 2,3-hydroxypropanal, and we're going to try and see how this argument was. Now this basically, which is a fundamental molecule of carbohydrates and stereochemistry that we have already looked at, or we're going to look in some of our other videos in the discussion under the topic of stereochemistry. And we're going to see that according to Fischer, he argued that with the carbon chain vertical and the hydroxide or the aldehyde carbon at the top. So in this case, he's trying to illustrate how this specific representation can be given as such. And we're going to see that at the top, the carbon chain is going to be aligned in a vertical way. So we're having carbon number 1, 2, 3 being given under this one as 1, 2, 3. So they have been aligned in a vertical way. And the aldehyde carbon at the top, which basically, as we can see, this is the functional group for aldehyde. So therefore, it's going to form this part of at the top. And the carbon number 2 hydroxide group that is pointing to the right. So this hydroxide group with the carbon number 2, so this is the carbon number 1, 2, 3. So basically the hydroxide group of the carbon number 2 is going to face to the right. And then we're going to have this particular representation for this specific compound. Now in this specific rearrangement, we can as well have a way in which this hydroxide group is going to point to the left. But for the orientation that the carbon number 2 hydroxide group is pointing to the right, therefore it's going to be given a designation for positive. So therefore, pointing to the right, this is the hydroxide group at carbon number 2. And maybe I can give it as that. So the designation for this name is going to be plus glyceraldehyde. And basically this is going to be given a different name. If it is pointing to the left. Then now for the left, I'm just going to do a slight orientation for this specific case to illustrate that specific point. Now suppose this hydroxide group that is here was to be realigned and be given this specific point. Therefore, we're going to have that Fischer projection over that molecule represented as such. And therefore, the name for that will change and be given as negative glyceraldehyde. And that will give two specific molecules for that specific chemical for glyceraldehyde. Now this is a stereochemical. There we will have a range of two stereochemicals for positive glyceraldehyde and negative glyceraldehyde respectively, according to this Fischer projection for the point or the rearrangement of this hydroxide group, either to the right or left respectively. I hope that point is understood.